Welcome to MarkScheme. Standard form, everything you need made visual. This is the number of atoms in a teaspoon of water, roughly 600 sextillion. And this is the width of a single atom, in meters. Both are almost impossible to write out. Too many zeros, and one miscount ruins everything. Mathematicians got tired of this long ago, so they invented a compact way to write any number, however huge or tiny. Watch. Each collapses into a tidy little package. A number between 1 and 10 times a power of 10. That is standard form. Here's exactly what this covers, straight from your syllabus. IB analysis and approaches. Standard level 1.1. First, what the form 8 times 10 to the k actually means. Then converting to and froming ordinary numbers. Then all four operations. Times, divide, plus and minus. And finally, your calculator's own shorthand, the e-display. Tick all four and you've got the entire subtopic. Here's the big picture, and it's the whole reason standard form exists. Lay out a ruler, but instead of ordinary steps, each step multiplies the scale by 10. On the far left, 10 to the minus 9 meters, the size of an atom. On the far right, 10 to the 21, the width of our galaxy. Now slide along. The little exponent k is doing all the work. It counts how many factors of 10 you are away from 1. Every 3 steps to the right, everything gets 1,000 times bigger. From an atom, up past your own height, at 10 to the 0, up to a city, and on out to the entire Milky Way. 30 orders of magnitude, and that one small number, k, tracks the lot. That's the payoff. The AA chooses the exact number, between 1 and 10. The k chooses the scale. 2 small pieces, and you can write anything in the universe. Let's make it precise. Here's a second way to see it that makes everything click. Standard form takes any number and hands 2 separate jobs to 2 separate pieces. The A, here 6.022, carries the digits, the precision, the significant figures. It says what the number is. The power of 10 carries the scale. It says how big, or where, the number sits on that ruler we just drew. And that split isn't just tidy. It's exactly how every calculator and computer stores numbers internally. A fixed set of digits times a scale. Separate the what from the where, and standard form stops being a chore and starts being obvious. Standard form is a times 10 to the k, and there are 2 conditions that make it work. First, a must be at least 1, but less than 10. So there's exactly 1 non-zero digit in front of the decimal point. Second, k is an integer, a whole number, which can be positive for large numbers, negative for small ones, or 0. Why insist a stays between 1 and 10? Because it forces every number to have exactly one standard form. 6.02 times 10 to the 23 is allowed. 60.2 times 10 to the 22 is the same value. But it's not standard form. A is too big. One number, one form. 2 quick notes. A plain number between 1 and 10, like 7, is just 7 times 10 to the 0. K can be 0. And the negative number keeps its minus sign out front. The A is always the positive size. So minus 3000 is minus 3 times 10 to the 3. Converting is nothing more than counting how far the decimal point moves. Take 6,730,000. To make a sit between 1 and 10, we put the point after the 6, 6.73. The point jumped 6 places to the left, so k is plus 6. Now a small number, not point, not, 4, 2. This time, the point must travel the other way, 4 places to the right, to land after the 4. Moving right makes k negative, so it's 4.2 times 10 to the minus 4. The single rule. K is how many places the point moves. Positive going left, negative going right. Now the arithmetic, starting with multiply and divide. And the reason is pure index law. 10 cubed times 10 squared is 3 tenths multiplied by 2 more tenths. 5 tenths altogether, 10 to the 5th. So multiplying powers of 10 just adds the exponents. That's the engine behind everything here. So for two numbers in standard form, gather the front numbers and multiply them. And gather the powers of 10 and add the exponents. To divide, you divide the fronts and subtract the exponents instead. Handle the a's, then the powers. That's the whole move. But there's a catch that trips people constantly, and fixing it is worth marks. When you multiply or divide, the new a often lands outside 1 to 10, and then it isn't standard form yet. You re-normalize. Slide the decimal point back into range and adjust k to compensate. Say a multiply gives 40 times 10 to the 11. 40 is 4 times 10 to the 1. So pull that extra 10 into the power. 4 times 10 to the 12. The point moved left, so k went up by 1. The other direction. Suppose you get 0.3 times 10 to the minus 3. Now a is too small. Write 0.3 as 3 times 10 to the minus 1, and combine 3 times 10 to the minus 4. This time, the point moved right, so k went down by 1. Left, k up. Right, k down. The value never changes. You're just reparking the point. Adding and subtracting is the one that catches people out, because you cannot simply add the fronts when the powers differ. That's like adding a length in meters to a length in kilometers without converting. So step 1 is always match the powers. Take 3 times 10 to the 5 plus 4 times 10 to the 4. Rewrite the smaller one, 4 times 10 to the 4, as 0.4 times 10 to the 5. So both share 10 to the 5. Now that the powers match, you can add the fronts. 3 plus 0.4 is 3.4, keeping 10 to the 5. 3.4 times 10 to the 5. Match the powers, add the fronts, and check a is still in range at the end. Let's climb a ladder of examples. Easy to hard, all my own numbers, all IB style. Warm up first, 2 times 10 cubed times 4 times 10 to the 5. Multiply the fronts, 2 times 4 is 8. Add the powers, 3 plus 5 is 8. 8 times 10 to the 8. A is 8, already between 1 and 10, so nothing to re-normalize. That's the clean case. Now a standard applied one. A radio signal travels at 3.0 times 10 to the 8 meters per second. How far in 2.5 times 10 to the minus 3 seconds? Distance is speed times time. Multiply the fronts. 3 times 2.5 is 7.5. And add the powers. 8 plus minus 3 is 5. 7.5 times 10 to the 5 meters. A is 7.5, still in range. So we're finished. Notice the shape of the answer. State the formula, substitute, then the value. That's how method marks are awarded. Harder now. A division that forces the renormalizing step. 2.4 times 10 cubed over 8 times 10 to the 6. Divide the fronts. 2.4 over 8 is 0.3. Subtract the powers. 3 minus 6 is minus 3. So far, 0.3 times 10 to the minus 3. But watch 0.3 is less than 1. So this is not standard form yet. Renormalize. Write 0.3 as 3 times 10 to the minus 1. And combine the powers. 3 times 10 to the minus 4. The point moved right. So k dropped by 1, from minus 3 to minus 4. That final tidy is exactly the mark students throw away. Last rung, a subtraction, where matching the powers is everything. 6.4 times 10 to the 7 minus 9 times 10 to the 6. The powers differ, so rewrite the second with the bigger power. 9 times 10 to the 6 is not. 0.9 times 10 to the 7. Now both carry 10 to the 7, so subtract the fronts. 6.4 minus 0. 0.9 is 5.5. 5.5 times 10 to the 7, and A is in range, so we're done. If subtracting the fronts had dropped below 1, you'd renormalize, just like before. Now the exam craft. 5 things that turn correct maths into full marks. First, your calculator displays standard form with a capital E, 7.5E5. That E just means times 10 to the. It is calculator shorthand, never write it in your answer, or you lose the mark. Second, when you type these in, use the E, or times 10 key, rather than typing 10 to the power. It bundles A and K and stops bracket slips. Third, after every multiply or divide, glance at A and renormalize if it has drifted. That tidy is worth marks. Fourth, whenever a question asks how many times bigger one thing is than another, just subtract the exponents. 10 to the 23 against 10 to the minus 10 is about 33 orders of magnitude. And fifth, remember, the SI prefixes are simply powers of 10. Nano, micro, milli, kilo, mega. And on paper 2, give 3 significant figures. Before the recap, the 4 traps. 1. Leaving an outside 1 to 10. 75 times 10 to the 4 isn't finished. Renormalize to 7.5 times 10 to the 5. 2. The sign of k for small numbers. 0.004 is 4 times 10 to the minus 3, not plus. 3. Adding the exponents when you should be adding the numbers. You only add powers when you multiply. To add or subtract, match the powers first. And 4. Writing your calculator's E notation as the final answer. 7.5 E, 5 is for the screen only. On paper, it must be 7.5 times 10 to the 5. Dodge these 4, and standard form is free marks. And that's SL 1.1, fully covered, what standard form is, why the rule is what it is, converting both ways, all 4 operations by hand, with the renormalizing step, and the calculator traps. Next in the course, arithmetic sequences, our first taste of patterns that grow. For more, that's MarkScheme.app. See you there.